Okay, these are review problems for Chapter 10, and we're starting on page 701, number 14. Identify a chord that is not a diameter for circle F. So here we have circle F. A diameter is just a chord that goes through the center of the circle, so AD is a chord that is the diameter, BE is a chord that is the diameter. So we want a chord so its endpoints have to be on the circle, but we don't want it to go through the center. So AE would fulfill that definition, and DE also would. So either AE or DE. Number 44, a brick path is being installed around a circular pond. The pond has a circumference of 68 feet. The outer edge of the path is going to be 4 feet from the pond all the way around. What is the approximate circumference of the path round to the nearest hundredth? Well, what do we know? We know that we have our pond here and the path going around it. The path is 4 feet from the pond all the way around. So 4 feet, 4 feet, 4 feet, all the way around. We know that the circumference of the pond is 68 feet, so we have this circumference. We want to find this circumference, the circumference of the path. So I went ahead, excuse me, I called my pond radius, radius 1, and my path radius, radius 2. Now, what do we know in terms of each other? I know that radius 2 can be found by taking radius 1 and then adding 4 onto it. So maybe I want to write that down. So radius 2 is equal to radius 1 plus 4. Okay. In order to find the circumference of the path, so circumference of the path, that's going to be equal to 2 times pi times the radius, where the radius of the path, radius 2, is radius 1 plus 4. So 2 times pi times the radius, where the radius is radius 1 plus 4. Alright, so I guess we need to figure out what radius 1 is. Now, how are we going to do that? We know that what the circumference of the pond is, so the circumference, which is 68, is equal to, how do we figure circumference? We take 2 times pi times radius, where radius we're calling radius 1. So 2 pi radius 1. So we can set up our equation and solve for radius 1. The circumference, which is 68, is equal to 2 times pi times the radius. Solve this for radius 1 by dividing both sides by 2 pi. And now we have an expression for radius 1, or the radius of the pond. Notice that I didn't get a decimal approximation yet, because I've got some other calculations to do first. So from here I can take this expression and substitute in for radius 1 back here, and that will give me the circumference of the path. So we have the circumference of the path is equal to 2 times pi times the radius of the path, where the radius of the path is radius 1, which we now know is 68, divided by 2 pi, and then plus 4. So this is basically it. This is going to give us our answer. We just need to type it into the calculator the right way. So we want to take 2 times pi times quantity 68 divided by quantity 2 pi. So we see it divided by quantity 2 pi, then plus 4, and then close this quantity. And there you should get approximately 93.13 feet. 93.13 feet. And that's the circumference of the path. The next problem comes from page 702, and this is problem number 18. Circle J has a radius of 10 units. Circle K has a radius of 8 units. And BC is 5.4. Find each measure. We want to find CK. So the distance from here to here. Well, we know that the radius here is going to be the same as the radius there. And since we know that this is 5.4, we would subtract 5.4 from 8. So CK is equal to the entire radius minus this part of the radius, which gives us 2.6 units. Next problem is from page 710. We're looking at problem number 4. HK and IG are diameters of circle L. Identify each arc as a major arc greater than 180, minor arc less than 180, or semicircle equal to 180. Then find its measure. So if we want the measure of arc HI, that's obviously less than a semicircle, so that is a minor arc. And it's going to have a measure the same as its central angle. Well, we've been given the central angle 59 degrees, so my answer is just 59. Number 59 from page 713. The measures of arcs LM, MN, and NL are in a ratio of 5 to 3 to 4. Find the measure of each arc. If they're in this ratio, 5 to 3 to 4. That doesn't mean that that's their length. It means that, that whatever their lengths are, if we for example, if we simplify the measure of LM over the measure of MN, if we simplify that ratio, we would get 5 to 3 when we reduce. Or MN over NL, we would get 3 over 4. So there's going to be some factor here that we have to consider for each of these. So LM is 5x, MN is 3x, and NL is 4x. Now, all those measures added together should add up to 360. So you simplify and you get 12x, and you divide by 12 and you get x is equal to 30. But are we done? No. We wanted to find the measure of each arc. So the measure of LM is 5x. So 5 times 30 would be 150 degrees. The measure of MN is 3x. 3 times 30 is 90. And the measure of NL is 4x, and we get 120 degrees. From page 712, number 50. Find each measure. We want to find the measure of arc HGF. HGF. Well, we know that part of it is going to be 90 degrees. We just have to figure out what this other part is right here, and then add 90 to it. So, do we know the measure of angle HCG? No, but we have an expression for that. So HCG is 2x, so we have to figure out what x is first. How are we going to do this? Well, we know that HCD, we have another expression, is 6x plus 28. So we basically have this angle and this angle. Now what's special about those two angles is that they have to add up to 180. So we have 2x plus 6x plus 28 equals 180. 8x plus 28, combine like terms. 8x is equal to 152, subtract 28 from both sides, and therefore x is equal to 19. Divide both sides by 8. So now we know what x is. We can substitute that in to find a measure for angle HCG. So substitute in for x, and we have 2 times 19, which is 38 degrees. So if the central angle is 38, then the arc is also 38. So if the central angle here is 90, this arc is 90. Then we use arc addition. So we want to find the measure of arc HGF, so we're going to add 38 and 90, which is 128. From page 719, number 15. Angie is in a jewelry making class at her local arts center. She wants to make a pair of triangular earrings from a metal circle. She knows that arc AC is 115 degrees. If she wants to cut 2 equal parts off so that arc AB and BC are equal, what is X? So we want AB and BC to be equal. Since we have an expression for BC, we're going to call AC X as well. So we have X here, and 115 here. So that makes up the entire circle. So we're going to use arc addition and set all 3 arcs sum equal to 360. So we have X plus 115 equals 360. So that gives me 2x plus 115 is equal to 360. So let's subtract 115 from both sides, and 2x is equal to 245, and let's divide both sides by 2, and x is 122.5. So that's what x would have to be equal to, 122.5. Next we have number 20 from page 720. The snowboarding rail shown is an arc of a circle in which BD is part of the diameter. If arc ABC is about 32% of the complete circle, what is the measure of arc AB? So to figure the measure of arc AB, first we have to find the measure of arc ABC. Once we have that, the measure of arc AB will be equal to half of ABC. We know that because it says that BD is the diameter, so it's going to split this arc in half. So these 2 arcs are congruent. So what do we know? We know that ABC is 32% of the complete circle. So let's figure out what ABC is. If it's 32%, take 0.32 times 360, and you would get 115.2. So 115.2 degrees. But we only want half of that.